Okay, so here's what I've done since the last video. I've incorporated the LED counter, and it now counts up to 255, has all the characters in there. Basically, I changed out the JK latches for a multiplexer. Notice it just wraps around to 0. What I've got going up here, let me see if I can, there we go. What I've got going up here is the program counter. It just counts from 0 to 255. I've got that going out to the bus. The bus comes down into these wires, which goes over here to this EEPROM, which has the appropriate signals to light the correct segments of the 7-segment display. This 555 timer is going right here, which is just flashing on and off, which is causing this to the JK latch here to just invert and just pulse and become a counter 0, 1, 2, 3, and then it goes over here to this multiplexer, which then pushes it out to provide the ground for the 7-segment displays. Now, I'm going to pause it here, and let's see. Okay, so it's on 220, and so if I take register A and set that to be input and click the clock, I now have 220 in the A register, and it's basically on, off, off, which I'm assuming equates to 220. Now if I take that and turn off the input to the A register and I reset the program counter, notice it goes to 0, and I manually advance the clock, let's say 10, and I put that into the B register. I turn on the input to the B register, push the clock. Now notice I've got 4 zeros, 1 0, 1 0. That is 10 in binary. This says 11 because 11 is what's on the bus, but when I advanced the clock, that's what was latched into the B register. Now, I am going to take the program counter off the bus, and I'm going to put the new logic right here, which is my arithmetic unit, onto the bus. And notice I get the value 230, which is the 220 that we have in the A register up here, plus the 10 that's in the B register here. And so this is 10 plus the 220, which gives us the 230. But on the arithmetic, and I'm trying to get this focused here so that you can see it. It's hard to do with this camera. Right up here, I've got a switch that I can switch from the ground to the positive, and it'll cause the arithmetic unit to subtract. So it should say 210, just like it does. So now I'm subtracting 10 from 220. If I wanted to add it, I put it back in there, and I get 10 plus 220 equals 230. And basically the arithmetic unit is a chip that adds or subtracts binary. Basically it just adds binary, but the way it adds is using AND or gates to say, to say if this bit is lit and this bit is lit, then this is going to be off, but we're going to carry one to the next bit, and that's basically how it adds. The way it subtracts is over here. I have an inverter, and in binary I should draw this out, but I'm not going to because it's too late. But in binary, in order to subtract, you can invert all of the numbers. Every 1 becomes a 0, every 0 becomes a 1, and then add 1, and it basically becomes your the difference between the A register and the B register, so 210. So that's what I've done. That's where it is right now. It's not not a lot of progress. I've cleaned up the board some. I've replaced a lot of the wiring. This will go away once I extend the bus down, but that's for another day. It's just I've got other things I want to add, including RAM, and I actually want to add an instruction module, so I can actually write in something like load A with 220 and then add 10 and have it come out on the bus. And so all of these switches that you see me doing are all going to be controlled by software, and that's literally what makes it a computer, not just a piece of machinery. So there you go. That's where I'm at.